Hello guys, this is Mr. Garcia, your geometry teacher, and I'm making videos now to kind of supplement what we go over in class. So for those of you guys that can't go to class or because your internet's lagging and you're having trouble understanding me, this is for you guys so that you can go back, rewatch what you need to understand what we went over in class. I don't I'm not going to try to upload the recorded classes because those are too long. Our class is about an hour long and there's no need if I'm just going to cover the most important parts here, right? So that's what I'm going to do. And hopefully it helps you guys out. Please let me know if it does. I would love to know if it helps you or if you got something that you want me to do better. Please let me know. I definitely want to know if there's something that I can improve. So this video is going to be about slope. So this is lesson 1.4. And let's review our objective before we start here. I can derive the slope formula and use it to find slopes of segments. We're going to break off this lesson into three parts. In the first part, we'll talk about the length of segments, how we can find that length. In the second part, we'll actually look at the slope formula itself and how to use it. And in the third part, we'll look at the slope of parallel and perpendicular lines and how those are related. So let's start by figuring out how to find the length of horizontal or vertical segments. Now notice that I'm not going to talk about the lengths of diagonal segments here because that's going to be a different topic for a different day. Let's look at this example. Segment AB. I want to find the length of this segment where point A is 2, 2 and point B is 7, 2. So to find the length of this segment, especially if I have a graph provided, it's really straightforward. I'm going to plot my points. So 2, 2 right here is going to be point A, and 7, 2, which is over here, is going to be point B. So if I draw that segment between them, now I want to measure this segment, find its length. So like I said, if I have the graph, it's pretty straightforward because all I really have to do is count. I can count the distance between those 2 points. And if I counted 1, 2, 3, 4, 5, my length here is 5. Now that's the easiest way to find the length of the segment, especially if I have the graph. But we're not satisfied with that because I want to know one way that I can find the length of a segment if I don't have a graph, because I'm not always going to have that graph available, right? So I need to figure out what can we do to find the length of a segment if there's no graph available. So let's look at the next example. Here, we're going to look at the algebraic method of finding the length of segments. We need to find the length of segment CD, where C has the coordinates 4, 8, and D has the coordinates 4, 3. If I look at both of these segments, and I'm going to line them up here to make it a little bit easier, I have 4, 8 for point C, and for point D, I have 4, 3. Notice that in both of these, the x coordinate is exactly the same, right? Now, if you remember our previous example, in this case, the y coordinate was the same. And our line ended up being horizontal because right here is where y is 2. So it makes sense that the line would be there. Here, the x are the same. So what that tells me is if I imagined a graph, and obviously we have no graph, so we can't use this, but let's say that I did have a graph. Here's my x coordinate of 4. So my points would be arranged this way, vertically, because I have the same x coordinate. So we know that the x coordinate is the same, but that's not going to help us find the length of this segment. The length of this segment is going to come from 8 and 3. So we need to figure out what can we do with 8 and 3 to get the length of that segment. For that, let's go back to our previous problem again. Now, if we look at the x coordinates, right? X here is 2 and x here is 7. So when we think about what can we do, let's look at 7 and 2. What can I do with 7 and 2 to get 5? Can I add them? If I add them, that'll give me 9, so no. But if I subtract them, very interestingly, my answer is the same as the distance. What this tells us is that if I subtract whichever coordinate are different, the difference in those coordinates gives me the length of this segment. So here, I know that I can subtract 8 minus 3, and that happens to give me 5 as well. So the length of this segment will also be 5. That doesn't mean that the length of every single segment in the world is 5. It just happened to turn out that way here. So now that we know how to find the length of a segment algebraically, remember this will work for horizontal segments too. In that case, the y coordinates would be the same, and we would subtract the x coordinates. So now that we know that, let's look at our definition of slope again. Remember that slope, what that means is the change in y divided by the change in x. When we do that, that number that gives us, that number that's the answer to that, tells us how steep a line is. So for example, if we look at this line, it's not too steep, right? So I would say that the slope of this line is pretty low. But we're going to look at how to calculate that now. First, though, we need to know how to calculate it. And for that, we're going to need a formula. Now, the change in y just tells me how much the y segment is. So for example, remember when we did this? We have a y segment here, a vertical segment. So that change in y is just the length of my vertical segment. And we know that we can subtract them, right? So let's write it this way. Let's say that we have y2 minus y1. Since we have two y coordinates, we'll tell them apart with these little subscript numbers, y2 and y1. Now, if we subtract them, we'll get that change in y. On the bottom, change in x just means the difference in the x coordinates, the length of that x segment. And we're going to do the same thing. We're going to subtract our x coordinate. Now we have x2 minus x1. And that's our formula. This is the slope formula right here. Remember that slope? We represent that with the letter m. So m equals y2 minus y1 divided by x2 minus x1. Now there's a couple of things that we have to be careful about this formula though. Two main rules that we need to watch out for, and I'm going to write them out here. The first rule is that we never switch the ones and the twos. So what I mean by that is our y2 minus y1 and our x2 minus x1 always have to be in that order. y2 minus y1 always has to be like that. x2 minus x1 always has to be like that. If you try giving me this, y2 minus y1 over x1 minus x2, this will give you the wrong answer. You don't want to do this. Now, y2 and y1, x2 and x1, how do you tell those apart? We're going to look at that right now in our example. So don't worry about that. But the main thing to remember first is that your 2's and your 1's always stay in their side. Now, the second rule with slope is that we always subtract. We always subtract the 1. So like the y1 or rather and the x1. I say this because if y1 or x1 ends up being a negative, a lot of people like to say, oh, well, it's already subtracting, so I don't need to put the negative in, right? Because it's already subtracting. No. When y1 or x1 are negative, we need to make sure that we still have this minus sign and then minus negative, whatever that number is. And we'll look at that in the example right now too. But keep these two rules in mind because a lot of people mess up because of these two. Let's take a look at our example now. Find the slope of GH, and this is segment GH right here. Now I'm going to do each point in different colors. So I have red and I have blue. Find the slope of GH if G is -9, +4, and that'll be the point up here. And I ran out of space in my graph, so I had to extend it a little bit. I hope you guys don't mind. And H is 6, -5, and that'll be down here. So point H, 6, -5. And now I want to find the slope of this segment. Since I have my endpoints, I can use those. So I know that I'm going to use my formula, my slope formula. So now, how do I know which one is x2, x1, and which one's y2, y1, which one's whatever? So what we're going to do is to find which one is x1, y1, and x2, y2. Let's use green and purple to tell those apart. You get to label whichever point you want x1, y1, or x2, y2. I always do the first point x1, y1 just because it's first. And I'll do the second point x2, y2. The key is that you label it. You write it down. Under the point, over the point, next to the point, doesn't matter. But make sure that you label x1, y1, and x2, y2. So that way you know for sure which one is x2, y2, x1, y1, and you know exactly where they go when you plug them into the formula. So let's start with the formula. I'm going to draw my line here because I know it's y over x. And I'm going to start with my y2. y2 here is -5. So I'm going to write -5 minus y1 is +4. I didn't want it blue, I wanted it green so that we match. So there we go. And then on the bottom, I'll have x2 minus x1. So x2 is +6 and x1 is -9. Now here's where rule number 1 applies. Notice that I have -9. So here's, like I said, where a lot of people mess up. They'll say, oh, it already has minus, this has minus, so I just put 9, right? No, you don't put that. You don't do that. What you're going to do is you have minus here no matter what. Minus -9. And I'll put the -9 in parentheses so that I know I need to have that negative. So I get 6 minus -9. Minus negative. Yeah, it's weird. But this is the easiest way to remember. Because like I said, so many people mess that part up. So this is the easiest way to remember that you have to subtract the negative when this is a negative. Now, if your coordinate is positive, like this +4, then there's no need to worry. It's -4, right? But when it's a negative, that's what trips people up. So remember, minus, negative, whatever. At this point, you would plug this into the calculator. So Desmos has a very sweet calculator that you can use. Either the scientific or the graphing one will work. So you can just plug that straight in there and it'll give you your slope. But because I'm a math teacher and I'm awesome like that, I'm going to do it by hand. Mentally, old school. Yeah. So -5 minus 4 gives me -9. And 6 minus negative 9 gives me positive 15. Now this fraction can be reduced because I see that I can divide 9 by 3 and I can divide 15 by 3. So if I divide the top and the bottom by 3, I can reduce this fraction down to negative 3 divided by 5. And that's my slope. If I want to confirm that slope, I can look at the graph itself. Now remember that from left to right, starting from the left, moving towards the right, if my graph is going downwards like it is right now, this is going to have a negative slope. If it was going up instead of down, it'd be positive. But this is a negative slope because it's rolling downhill here. Okay, so that checks the negative part out. What about the 3 over 5? Well, I can choose 2 points. I can use those points if I wanted to, but I'm going to choose 2 points that are even closer. So let's say I choose that point to start. Now my slope tells me the length of my vertical segment and the length of my horizontal, right? So I know that the top number, the negative 3, is my y segment, vertical, and the bottom segment, my 5, is my x, the horizontal. So negative tells me that I'm going down. So from this point, I'm going to go down 3. 1, 2, and 3. What am I doing? Let me choose the pen. I had the arrow selected. So 1, 2, and 3. Sorry about that. So here's my vertical segment, and that's my negative 3. So now I move 5, and this is positive, so I move to the right. So I go 1, 2, 3, 4, and 5. And hey, look at that. We hit our line again. So that confirms that our slope is negative 3 over 5 because we go down 3 and across 5. And we can go down 3 more and across 5 and it'll hit the line again. Down 3 across 5, down 3 across 5. We can keep doing that because that is the slope of our line. Now we're going to talk about the last part, which is with parallel and perpendicular slopes. So let's start with parallel because that's super straightforward. Parallel lines, look at the example here, and you'll notice that they both run in the same direction. And hopefully you remember that parallel means two lines that go in the same direction. They will never, ever, 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 ever cross. They'll never touch each other. They're afraid of each other. They got cooties. They don't want to touch each other. So they will always run side by side, but will never actually cross each other. Now, what that means as far as the slope, and if you'll look at the diagram, the picture here, the blue line has a slope of 2, and the red line has a slope of 2. So parallel lines have the same exact slope. Look at the example here at the bottom, where I have two equations, y equals 4x plus 3, y equals 4x minus 8. These two lines will be parallel because they have the same exact slope. Now, perpendicular is a little bit different. It's not as straightforward. So let's take a look at perpendicular. Perpendicular will have their slopes as opposite reciprocals. Now, that's some pretty advanced vocabulary there. So let's break that word down, opposite reciprocal, and see what it's actually telling us. So the opposite part here, the word opposite in this context means to switch the signs. So here the opposite means switch signs. And what I mean by sign is our positive and negative. If it's already positive, it switches to a negative. And if it's already negative, it switches to a positive. Basically, it switches to whatever it's not. If it's positive, obviously it's not negative, so it goes to a negative. And if it's negative, it's not positive, so it goes to a positive. That's what the opposite means, not the reciprocal. Now choose a green for this. So the reciprocal part is a little more complicated to understand. But what it basically tells us is flip the fraction. So the reciprocal part tells us to flip the fraction. To better understand what that means, take a look at the picture. The slope of the purple line is 2 over 5. So we have a rise of 2 and a run of 5. Now we know that these lines, the purple and the green, they are perpendicular because they have that 90-degree angle where they intersect. So we know that perpendicular lines must create a right angle where they cross, and here we have that. So we know that these lines are perpendicular. So being perpendicular, we know that the slope of the purple line is 2 over 5. Now look at the slope of the green line. Negative 5 over 2. There were two things that changed here. One of them is that the fraction kind of flipped upside down, right? Whatever was on top is now on the bottom, and whatever was on the bottom is now on top. The 2 went to the bottom, the 5 went to the top. So that's the first change, and that's the reciprocal part, because the fraction flipped around. Now the other change is that the slope of the purple line is positive. There's no negative here, so we assume that it's positive. But the slope of the green line has that negative sign. So that's where the opposite come into play. The opposite tells us to switch the sign, right? So we know that these are reciprocal because we flip the fraction and we change the sign. Now here's something interesting. What if you don't have a fraction as your slope? Take a look at the equations down here at the bottom. You'll see that I have y equals 2x plus 5. Then I'll have y equals negative 1 over 2x minus 7. These two are perpendicular. But you're probably wondering, well, where did he get the 1 from? Or how did he even flip the 2 around? It's a whole number. It's not a fraction. So how can you flip the fraction if there's no fraction? I got the negative part down. There's my negative. But how did I flip the fraction? So the easy answer there is that we need to turn that whole number into a fraction. Let me write down the number 2. I want to turn this into a fraction so that I can do the reciprocal and flip it around. But the question then becomes, how do I turn 2 into a fraction but still keep it 2? Because if I do, for example, 2 over 2, well, that's going to divide and give me 1. So I don't want that. And if I do any other number like 3 or 4 or 5, doesn't matter, it's still going to divide it, and that's not what I want. But there is one number that can work. Because if I divide 2 by 1, it's still going to be 2. Anything divided by 1 doesn't change what the number is, no matter what. So even if I had, for example, 300 million whatever divided by 1, it's still going to be 300 million whatever. So we can use that to create a fraction out of a whole number. And now I can flip this around, right? I'll change the 2 to the bottom, I'll bring the 1 to the top, and that'll give me 1 half, 1 over 2. So that's the reciprocal part. Then the opposite part tells me to make it negative, so I do. And now my my slope for my perpendicular line is complete. That's pretty much it for this lesson, guys. If you have any questions, please make sure to reach out to me to remind or email or whatever. Let me know. Let me know if you have questions, please, because I want to make sure that you guys understand this material. All right. So that's it for today. I hope this helped you out. And again, please let me know if it does or doesn't, or what can I do better so that I can make these videos better and easier for you guys to understand. So with that said, I hope you guys have a great day, and I'll see you guys in class.